Okay, so we'll begin now. So, good evening, everyone. And yeah, I had to postpone this session to the today uh, due to some travel plans. And I'm not so well today, so please excuse my voice. If something is unclear, please feel free to ask again. I'll try to explain it as much as possible in a better way. Please. Yeah, please unmute yourself and ask questions in case I miss your query in the chat. Okay, so is there anyone who is joining for the first time? Okay, I assume you would have gone through the session recordings of the previous sessions, and this is session 6. So are you guys able to see my screen? Can you please confirm? Yes, no? Okay, thanks. So let's get started. So in the previous sessions, we saw a few concepts relating to Python, including all these concepts. We'll come back to these concepts later in the revision session, which will happen towards the end of this course. So we'll have 12 weeks plus one revision session. So, sorry, I'll try to cover all these concepts uh, during that session and clarify whatever queries you may have later. We saw a lot of different concepts, and in the last week specifically, we saw dictionaries, try except like exception handling in Python. We saw some more concepts or operations relating to Boolean variables. Then we touched upon Monty Hall problem and then saw bubble sort and then binary search. Sorry. So in this week, we'll do a brief recap of dictionaries and how dictionaries can be used for certain tasks. Then we'll see the string library in Python, like different operations that you can perform on string variables using the string library. Then we'll see some applications of recursion. We'll touch upon what recursion is and what it can be used for. So these are the two applications, binary search and Fibonacci series. We'll see more applications of recursion shortly after this. So, are there any queries from the last session relating to dictionaries or any of the topics? Yeah, please feel free to ask. I'll be happy to answer whatever queries you may have. Okay, so I assume, yeah, you are clear with all these concepts, but in case there are any queries, please let me know in the chat or unmute yourself and ask. Okay, so sorry. Yeah, for those of you who joined just now, so yeah, I'm a little unwell today, so my voice will not be that clear. So please excuse me for that. But in case you find something difficult to understand, please let me know. I'll try to explain it again. Okay. So just a brief recap of what dictionaries are. So as we saw in the previous session, dictionaries are nothing but collection of objects as similar to lists. But there is one more functionality which is added in dictionaries, which is the mapping. So, sorry. So the dictionaries contain key value pairs. For example, if I have a dictionary of students, and in that I have student name and the marks for that student. So I can have multiple such entries in the dictionaries with key and the value separated by colon, and each key value pair is separated by a comma. This is one way to initialize a dictionary. Okay, so let me just write this. So if you just print this, you'll get the entire dictionary. And if you want to access certain element in the dictionary, you can do it using the key values or the key entries. So for example, S1 is a key, and then if I try to access S1 element, so it will return the value corresponding to that particular key S1. Okay, so this is one way to initialize a dictionary. Sorry. Another way is like you declare a blank dictionary. This is not necessary though, and then you can. This is just for the cleanliness of the code. Like you are declaring beforehand that student is of the form of the type dictionary. But although even though if you don't declare it like this, you can still write, you know, S3 equals to, let's say, 27. And let me print students. Okay, it should be students, not student. Yeah. So what I have done over here, when I declared this as empty dictionary, the previous dictionary which I had declared got overwritten to an empty dictionary. And then when I'm writing this as S2, S3, students of S3 S27, it is creating an entry S3 and assigning it a value of 27. It is similar to declaring like this. So I could have done like this as well, S3 27. Or second way, alternate way is to do simply like add the key and then put a value corresponding to it. However, if you, as we saw in the previous session, if you try to use the same key and assign some different value, so it will override the previous value that you had. So let me print this. So in dictionary, every key is unique. And if you try to declare something, uh, some key again, and assign it some value, so the latest value of the key will be used in the dictionary mapping. Is it clear, everyone? Okay, fine. So yeah, so this was about the basics of dictionary, and then we saw like how you can, let me just use this again. So we saw like how you can access the keys and the values in the dictionary. So for example, if you want to access only the keys in the dictionary, so you can use students.keys. So it will return an object which contains all the keys S1, S2, S3. So if you want to create a list out of it, you can just simply pass on to the list constructor like this list and student.keys. It will return a list over here. Okay. Similarly, if you want to get all the list of values, so you can simply use students.values and it will give you all the corresponding values over here. And if you want to get the key value pairs, so you can get the key value pairs using this, sorry, items. It will return a tuple for each key value pair. So we'll see tuple shortly, uh, probably in the next session. So uh, these are the three things that we discussed in the last session. So why are we discussing dictionaries in this session? So there was one concept that was discussed in the class, uh, which is cipher or substitution cipher or Caesar cipher. So this is a part of cryptography. So let me quickly show it to you, show a demo to you on iPad. Okay, are you guys able to see my iPad screen? Okay, thanks. So, let's say you want to send some message, some confidential message to someone else. However, you don't want any information to leak in the on the way. So, there is one possibility that you encrypt this particular message, whatever message you have, let's say, using some encryption algorithm, and then send it across, and then at the receiver. So this is sender and receiver. So you are encrypting it, encrypting the message using some encryption algorithm, and then the receiver needs to decode that or decrypt it. So one important thing is this encryption algorithm, and then the receiver should know the way to decrypt that message again from the uh, already encrypted message. So, what are the ways in which you can do that? One simple way is like you have alphabets A, B, C, D, E, and so on. So, very simplest way of encrypting a message is shifting. Let's say I substitute A with D, B with E, C with F, and so on. So here I'm shifting this by certain positions, each alphabet. Okay. So this is since you are substituting uh, an alphabet with another character, this is known as substitution cipher. Cipher is nothing but a machine that you know converts a given text or encrypts a given text into another text using some algorithm. And in this case, you are substituting something with something else. So that's why it's called substitution cipher. And here, in this case, this is a special case of substitution cipher in which you are substituting every character by shifting it by certain positions. Like for A is, for example, A is substituted with D, B with T, C with F, and so on. Okay. So in this case, sorry. So this is the simplest way. Now, at the receiver end, the person needs to know only this information that by how many alphabets the uh, digits need to be shifted. For example, if I send this message, Saish, Saish, and what will be the substitution for this? Like if, let's say if I shift by 2, okay. So I want to shift this by 2. So it will be, S will be turning to U, A to C, I to K, S again to U, and H to J. So the new message text will be U, C, K, U, and J. Okay. So once the receiver receives this, and also the information is there that the decryption can be done by shifting it back by 2 letters, the original text can be decoded. However, if this decryption key is lost, like you don't know how to, get back the mapping. So in that case, there is no way. no simple way to decrypt the this original text back. Uh, However, there are certain ways in which you can, decrypt the original message provided you have sufficient amount of data with you. Like in this case, it was quite short, like, sorry. Yeah, so the text was quite short, like size. But if you had like long text, let's say 1 lakh entries, so in that case, you might be able to see by with the frequency analysis, like you know that certain letters in English, I'm assuming that the language is English, that the text, original text is in English, and you know that the certain letters in English are very frequent compared to the others. So if you try to see the distribution of, each character in the encrypted text, you can see that whatever is the most frequent in this encrypted one will be corresponding to the most frequent character in the original text sorry, in English. So you can use that information even if you don't have key to find out what the mapping might be for this encrypted message. Is this particular part clear, everyone? Especially this frequency analysis that I'm talking about. Yeah, please feel free to ask. I'll explain it again. Is it clear? Yes, no?
Sir, I didn't understand it perfectly. Could you
I
please
see.
explain
Okay.
it again?
So in English, let's say, so what we were discussing over here is that uh, you can send a certain confidential message by encrypting it with certain algorithm. By encryption, we mean that you substitute this each character in the original text with something else. So there is one way to do that. That is like shift every character by some positions. Like you replace A by C, at B by D, C by E, and so on. But this information should be there with the receiver that each character was shifted by 2 letters. However, uh, if this information is not there with the receiver, so there is another indirect way with which you can try to decode or identify what this decryption might be. Okay, so let's say, okay, I'll come to this later. So what I was trying to say, in English, certain letters like say E is the most frequent one. Then after that, let's say I. It might not be like exact ones, but please confirm it. So there might be like certain frequencies. So this is like the most frequent number one, two, three, four, and so on. So if you see in this encrypted text, you have some text, let's say some random text, and so on, which has no meaning as such. But in this, if you try to find out the frequency of each character, so you can identify like which character, so whatever character is having the most maximum frequency will be, we will kind of like assume that it is equivalent to the actual English character. So like let's say like in this case, the character Z is most frequent, which means that Z might be having be mapped to the letter E in the original text. So similarly, you can try to decode the other characters. So like if you have sufficient number of characters here, like it should the text that you have, the decrypted text should have all the characters, and then there should be like sufficient frequency of each character to make conclusion. Like if they don't have enough frequencies, like all the characters are like two or three, like has frequency of two or three, then in that case you may not be able to decode, what these original characters might have been. But if you have uh, like a lot of text data, then using that you can get a frequency histogram for each of this character in this decrypted text, sorry, encrypted text, and then using that information, let's say some U, X, uh, L, and so on. So this might be E, this might be S, I, S, H, and so on. So based on the actual knowledge that you have from the English text, which is means like the distribution which is taken from built from the actual English text from a lot of documents, you can use that to decode the information in the encrypted message. Is that clear? Sorry. Sorry. Is that clear? Yes, no?
Yes, sir.
Okay, great. So this was one way to substitute, like by shifting by certain uh, characters. So that is called Caesar cipher. However, you can even substitute randomly. So let's say A, B, C, D, E, F, and so on till Z. And then you have A, B, C, D, E, F, Z. So you can map any character to any random character. Okay, but you should ensure that each character is mapped to a unique character. So there should not be like multiple mapping. Like there should be one-to-one mapping in this. Okay, so this is another way of substitution in the substitution cipher. So this was a special case of substitution cipher in which you were trying to replace each character with certain shifting. However, in this case, it is a generic way in which you can, map any character to any other character. Even you can even map it to some other language script or characters. Like let's say the Greek alphabets. So you can map C to alpha, D to beta, and so on to encrypt the message. So these are different ways, to encrypt the message. And then the frequency analysis will be most useful over here because unless you have this mapping, you cannot decrypt the message. In the previous case, only information you needed was like the shift, like by how many digits you are supposed to shift. However, in this case, you need the entire mapping of the characters in the language or alphabets in the language. So if you don't have that, you won't be able to decode it. And the one way to get that information is through this frequency analysis that you can do by plotting the histogram and seeing which is the most frequent character and then mapping it to the actual English character. Okay, with the assumption that the original text is in English. Yeah, it is applicable to any other language. Like you have to but have the language knowledge of the frequency of the characters in those particular languages. Okay, so this was another case of substitution cipher. So why did we discuss all this? Encryption and mapping. So this is sorry, where you can use dictionaries in Python to map the original text character to the encrypted message character. For example, let's say I have 5 characters in English, and then I want to map it to Greek characters. Let's say A is mapped to lambda, B to alpha, C to beta, D to gamma, and E to delta. So in Python, I can write it as uh, sorry, A to lambda, D to alpha, and so on. Okay, so if I have a text, let's say uh, A, E, A, B, D. So I'll have to iterate over each character in this string and then use this map, get the corresponding, character or the mapping and replace that with that particular mapping. So let's say A is lambda, E is some delta, then A again lambda, then we come to B, we see the entry of B is alpha, and then D, LT of D is gamma, and this is your new message. Okay, so this was a basic application of dictionary for encryption purposes. So is it clear, everyone? Yeah, so it all depends, Aditya. So it should have sufficient, there is no clear answer for that, but at least it should have all the characters in the language so that you know the frequency of each character, and then from that you will try to decode the original text mapping or original character mapping. So it should not be too short, like, one or two words or something like wherein you don't have, which doesn't span like all the characters in the language, or alphabets in the language, and also the frequency of each character is like two, three or something. It should be like at least, 30 or something like where uh, uh, at least you can get some idea of how the frequencies are changing. So the most frequent one will be like having a highest frequency, uh, like you can see the peak over there clearly, and then the least frequent one will be like, so in this case the distribution will be something like this, like decaying distribution. So if you get this kind of a distribution, you should have sufficient number of examples for, you know get this kind of distribution. Okay, is it clear, Aditya? So if you don't have sufficient examples, the distribution might turn out to be like this, which is very close to uniform distribution. Like all the characters have uniform distribution. So in that case, you may not be able to distinguish, which is like actually most frequent one. It may happen that the not so frequent one may have more frequency in the given text, encrypted text. So to avoid that, you should be having a lot of text to avoid all these misinterpretations. So having as much text as possible will make it you know better to decrypt the or get the mapping back to the original text. Yeah, in that case you may not be able to decode it because you don't have sufficient data available. So whatever uh, data you have, you can infer something from it, but it does not guarantee that it will be exact mapping that you will have between the actual text and the encrypted text. Yeah. So this was all about encryption. So let me go back to Python. Yeah. So as we discuss, you can have a dictionary with actual character mapped to some other character, let's say C, and so on. Okay, so this is an example of substitution cipher wherein you will substitute each character with some other character. And it need not be like only English letters, it can be any alphabet. Let's say you want to have Greek alphabet, so let me just, sorry, copy this and put it over here. So you can have other characters as well as strings here. So this will take care of mapping it to the other language characters. So this was a basic example of dictionary. So let us see some questions and we'll move on to other concepts like string library, which also has an application for this encryption. So let us first see some questions and then we'll come on to string library and then we'll move into the discussing recursion. Okay, so I think recursion question is there in. Okay, fine. So let me discuss string and recursion first, and then we'll move on to questions. I'll switch to W3 schools for string library. Okay, yeah. So string is a library in Python. Like other libraries, NumPy, pandas we have not discussed yet, matplotlib, and so on. So it has multiple functionalities that you can use for string data types. For example, uh, if you want to convert uh, a lowercase string, let's say, just a second. Let me just check the actual function to convert lowercase to uppercase. Yeah, so there's upper function. So there are some inbuilt, uh, uh, strings that are defined in this string library. For example, ASCII letters. So it will give you all the characters in English alphabet, like from small a to capital small z and capital A to capital Z. Similarly, uh, if you want to access only the lowercase ones, A to Z, so you can use it, sorry, access it using ASCII lowercase, and similarly, the uppercase one will be can be accessed using ASCII uppercase. So why are we discussing this? Because this will give you a string of all the characters, alphabets in the uh, English language, which you can use to, so if I assign it to a variable, let's say A, B, and C, Let me run this. So A of 0 will be A of 1 will be B, and so on. So you know that from the index position, you can access a particular character. You could have simply declared it as, A equal to a string of A, B, C, D, E, F. But just to avoid this, Python has this inbuilt one, so you can directly use that. Okay, that's the basic application of this, one of the basic applications of this string library. And then there are other inbuilt functionalities like upper and lower. So let me just try it out. So if you just print this B and print B dot upper, so you'll see that all the characters in this particular string uh, in B got converted to the corresponding uppercase ones. Okay, so it can be anything. Let's say sample string. By the way, this way of declaring variable is called camel case. Uh, so you can see that each letter after the first word is capitalized. So you can also have this kind of declaration. So generally for variables, so this is not like hard and fast rule, but for variables you can use this camel case, and also you can use this kind of declaration wherein you separate different words with underscore and so on. So there are different names for these naming conventions. So you can look into it later. So sample string, uh, my name is Saish. So let me print sample string and print sample string dot upper. So you can see that all the characters in this particular string, my name is Saish, is like are converted to the corresponding uppercase ones. Similarly, you have this lower one, so you can convert all, sorry, not lower, all the characters to lowercase. So whatever characters are already in lowercase will remain as it is. Whatever are in the uppercase will get converted to lowercase with this lower function. Okay, so these are some operations you can perform on this string. Okay, is it clear, everyone? This might be too basic, but I just want to discuss it because it will be needed for some of the questions that we'll be discussing. Okay, great. Okay, so this was all about the string library. So there are other functionalities as well. You can even replace certain things. So let me just try see an example of replacement. Yeah, so here is an example. So I have this text, and if I do text dot replace and I want to replace something with something else. So let us try this out in Colab. Okay, so I like bananas, and I am replacing this bananas with apples. What if I replace a character with something else? So you can see that I like bananas becomes I like ananas. Okay, so all the B, like wherever B is coming into picture, that is getting converted to A. So this is an example again, wherein you can perform certain operations on strings. Okay, let me see what is left. Yeah, I think that's it. So we'll move on to recursion and then we'll see some examples and conclude this session. Some questions on recursion and then whatever concepts we have discussed so far, and then we'll conclude. So let me share my iPad screen again. Okay, are you guys able to see the screen, iPad screen? Okay, great, thanks. So, the basis of recursion is that you can use already computed values to get computation for the next level. For example, factorial. So I assume each of you know what factorial is. So factorial is nothing but like uh, let's say n factorial is like 5 factorial is 5 into 4 into 3 into 2 into 1. And similarly, n factorial is n into n minus 1 into n minus 2 into so on till 1. So if you know the value of factorial 4, you can simply multiply it by 5 and then get the value of factorial 5. So factorial 5 is nothing but 5 into factorial 4. Factorial 4 is nothing but 4 into factorial 3 and so on. 3 into factorial 2, 2 into factorial 1, which you know is 1. Okay. Now you use this information to compute 2 factorial and then use this information to compute 3 factorial and so on. Okay. So there are two things to notice. One is you're calling the same functionality again, like you're making a recursive call to the same function, like let's say factorial. So you're calling factorial here, and then there is, sorry, there is a base case here on which you stop. So there are two things you should be noticing over here. One is recursively calling uh, the same function and then stopping at the base case. So this is very important. So if you do not have this base case in any of these recursive calls, your program might end up running into infinite loop. So to avoid that, you definitely need to have a base case. So this was one example of recursion. There are other examples like Fibonacci series. So you would have known what Fibonacci series is. So it's nothing but sum of the first two letters characters in the or no, digits in the Fibonacci series are 0 and 1, and all the subsequent digits are computed by summing the previous two digits. For example, the third digit will be 1 plus 1. The next digit will be 1 plus, sorry, 0 plus 1. Next will be 1 plus 1. The next one over here will be 1 plus 2, which is 3. The next one will be 2 plus 3, 5, and so on. Okay. So in this case, how you are formulating the factorial? So factorial of n any digit n is equal to factorial of n minus 1 into n, or n into factorial of n minus 1. So you are recursively calling this function, and then you will have to stop at certain function. Like if the value of n is 1, then you just say that the corresponding value is, or the return value is 1, and then it will start unfolding. Okay. Similarly, in this case, Fibonacci of, let's say, n can be written as, can somebody mention, write it in the text or chat, or unmute and answer? Anyone? Fib is just a short form for Fibonacci. Anyone would like to answer? So every digit was formed by summing up the previous two digits. So the nth digit,
N plus 1.
no, so previous one will be, so the previous character, so this is like the nth index. So this is like first index, second index, third, fourth, fifth, sixth. So if I want to get a Fibonacci of 5, so what will be, how I can compute it with the previous ones? So Fibonacci of 5 will be nothing but Fibonacci of 4 plus Fibonacci of 3. Do you agree?
Yes.
Yeah. So Fibonacci of n will be nothing but Fibonacci of n minus 1 plus Fibonacci of n minus 2. Okay. Yeah. So it should be function Fibonacci of n minus 1 and n minus 2. And however, it is applicable till 3. And then in this case, you will notice that you need at least two elements, right? So if you are on 2, you can have Fibonacci of 1, and there is nothing called as Fibonacci of 0. So in this case, these are the two base cases that you have. So you predefine this, that if it is, if n is 3, sorry, if n is 1, you return 0. If n is 2, you return 1. And if n is 3 or more, greater than or equal to 3, then it will be Fibonacci of n minus 1 plus Fibonacci of n minus 2. Is it clear, everyone? In this case, you are having two base cases. In this case, you had only one base case, that is n equal to 1 in the factorial case. Whereas in the Fibonacci case, you have two base cases. Is it clear? If it is not, sorry, I'll explain it again. Yes, no, please confirm. Okay, thanks. So, two things again. A function calls itself with some other value, and then uh, uh, there is a base case necessary for any recursive functions. Okay, and then there's one more thing that I wanted to discuss was this binary search. So in the previous session, we saw binary search in which the requirement was that the array should be sorted or the list should be sorted. So let's say I have this list of numbers and I want to find some number, let's say 3. So first of all, I'll go to the middle element, compare which one is the, if the number is, if the number I want to find is shorter than or uh, larger than the given number. If it is shorter, less than the given number, so the number is likely to be on the left hand side, else it will be in the other half. Okay, now my search space is reduced to this particular sublist, a subarray. In that case, I go to the middle element and then check for the uh, uh, given half based on the value that you want to search for. Okay, so this particular thing can be done recursively. Okay, so let us discuss few questions and then we'll come to this. So are you guys able to see my screen? Okay, yeah. So which of the following is true about recursion? There can be multiple options correct in this case. Vivek, what is it for? Like, did you not understand anything or is the screen not visible?
Is screen is not visible, sir.
Um, I think I have shared it and it's visible to others. Maybe you should try rejoining or, um, changing your connection network.
Okay, sir. I will rejoin.
Okay, yeah. So please try to answer this.
Option B and option D.
Okay. Okay. So let me discuss the answer. So the correct answers are B, C, and D. So recursive code can be reused as we saw in the factorial example and the Fibonacci example. Sorry. So let me share the screen again, iPad screen again. So let's say you want to compute. So the generic way to write Fibonacci is, or let's say factorial, is fact of n minus 1 into n. Okay, so you're calling the function again and multiplying it with n. And the base case is if n is 1, then return 1. Okay, so this code can be used for any value of n. N can be any value greater than 1 and so on. If it is less than equal to 1, you'll have to throw error that it is, sorry, less than equal to, sorry, if it is less than 0, you'll have to throw an error. By the way, 0 factorial is also 1, and there is a proof for that. So I won't go into the detail of it. So this is a basic thing. So I'm taking here base case as 1, but base case can be 0 as well in this factorial case, wherein 0 factorial can be treated as 1. So this is there is some proof for that. So let us avoid discussing it here. So yeah, the point over here is that you can reuse this function. So how you could write this in Python? So you have to define factorial. Let's say I'm defining factorial function as fact. I'm giving input to the function, and then if n is, let's say, 1, then return 1. Else, I don't want to, I have to write anything here. Else return n in, sorry, into fact of n minus 1. Okay. So as you see, the base case here, you will have to write if, error over here as well. Like either you can write it here or before giving calling this function. So you can either write if n is less than 0, print this is not possible something, and then you can have n equal to 1 or n equal to 0, then you can return 1, um, and return n minus 1 otherwise. Sorry, n into a factorial n minus 1 otherwise. So you have a base case and then you have a recursive call. Okay, so you can reuse this function for any value of n. So this was the first one of the options. Other option was the base case is necessary for recursion. This we have discussed. If it is not there, then the loop will just keep on like this n minus 1 will be called again and again, and it will never end. Okay, so to stop it at certain point, you will have to have a base case. Then uh, recursive code can be shorter than non-recursive code. Yes, this is true. In certain cases, it can be shorter. Maybe I'll discuss it later. I'll have to look into some examples wherein the non-recursive code will or the iterative code uh, looks really clumsy than the recursive code. However, one important point that needs to be taken into consideration is that recursion is not always faster than the non-recursive code. The reason being, in recursion, you are making some unnecessary calls again and again. For example, fact, let's say Fibonacci. Fibonacci of 5 will call Fibonacci of 4 and Fibonacci of 3. Fibonacci of 4 will call Fibonacci of 3 and Fibonacci of 2. This will call Fibonacci of 2 and Fibonacci of 1. These are the base cases. This is the base case. And then this will call Fibonacci of 2 and Fibonacci of 1. So you can see that Fibonacci of 2 is being called multiple times. Fibonacci of 1 is being called multiple times. And 3 is called over here and here as well. So you're making the same function calls multiple times. So you're like adding extra overhead on the computation. So in certain cases, uh, uh, recursive algorithm might look cleaner. However, computation wise, it is not always faster. because it ends up making some unnecessary calls, function calls. Okay, so let me go back to the question. Sorry. Yeah. So which of the following is true about recursion? Recursion always performs better than non-recursive code. This is not true, as we saw in the example that it makes some unnecessary calls. Recursive code can be used, yes. The base case is necessary, yes. Recursive code can be shorter than non-recursive code. We'll see this shortly. Okay, there is another question. So think over it. We'll maybe skip it for the in view of time. So Python is encoded by TCXLSR. Then diamond will be encoded as, provided this is the Caesar cipher. So you can see that what is the number of shift that you are having here. So based on that, you can identify a pattern and then try to decode or encrypt this particular word. So just try for some time and we'll probably skip the explanation for this. Anyone who got the answer? So yeah, can you quickly mention how you got the answer? You can unmute yourself and answer.
Sir, there is 4 gap between each number.
Mm-hmm. Yeah.
So
So
that's why calculate 4 spaces and calculate it.
yeah, thanks. So yeah, this is simple. So you just have to shift each character by a certain number, certain positions, and then try to see like what is the pattern here, and then by the same following the same pattern, you'll have to convert this particular string to that. Okay. So yeah, we have not discussed this in the random library, but let us see this. So let L be a list of L be a list containing different names of movies. Which statement is correct to select a random movie name from that list L? For those of you who know, okay. So let me have this list M1, M2, M3, and so on. I'll import random library, and random has this particular function called choices. So this will give you one random movie from this list. So every time I run this, it will give me some random. Okay. So you will see more randomness when you have like lot of movies over here. So the correct answer over here is random dot choices. Random dot random and random dot movie does not exist. Random dot random, we saw it was for something else. So let me just uh, show this random audio. So you'll see all these functionalities in random library. So see, this is to set the random value generation. Like so, there is an algorithm that runs uh, in the backend for random value generation. So to set up a seed for that, so that like every time you run a particular code, let's say you are having some machine learning model, and you're trying to uh, let's say there is a model, there is an algorithm called k-means clustering. So it clusters different data points. So if you want the clusters to be same every time you run that algorithm, you will have to set this random number generator seed to certain value to ensure the reproducibility of the results. Otherwise, every time you run this, it will generate some random clusters, which is not expected in certain cases. So for that, you will have this seed. Then you have different functions here. So you will see the choices here, and then random, which returns a random float between 0 and 1, and so on. So you can take a look at it. You need not remember all of this, but this specific ones like random, choice, and randint, whatever we have discussed so far, and rand range. That's it. Okay. So we'll come to seed later. Make if in case I discuss something relating to some other machine learning algorithm, I'll come to the seed functionality again. Okay. So the correct answer over here is random dot choices. Okay. In this list, L, what is the index of element 7? So this is like a very simple question, so I'll just skip it. So answer is 0, 1, 2. So 2 is the answer. Okay. So this is something we need to discuss now. So there is this code. Take some time to analyze what exactly is happening over here. So meanwhile, I'll just try typing it in Colab. I hope you are able to see. So there is import string. Then there is a function called shift, which accepts two parameter word and value. And then there is this variable called letters, which is taking the string.ascii lowercase. And we saw what this returns. Then there is this new variable, which is having an empty string. Then there is a loop which iterates over length of word, and then if word I in letters, index equal to letters dot index, new equal to new plus letters index plus value mod 26, else new equal to new plus word, return new. So let me type this out on, so it will be clear here. So that we are importing a string. Yeah. Meanwhile, I type, try to decode like what exactly this particular function is doing. By the way, I did not discuss this. So index will simply return the index. So like if letters is a string, so letters dot index will return the index of that particular character or string or whatever uh, in the given string. Could anyone identify what exactly this function is doing? Okay, yeah. So some of you have already got it. So yes, the correct answer is A. Shift every letter in a given word by value. So let us try to see one by one what's happening over here, step by step. So you are importing this string library to use for getting the string of lowercase letters, alphabets. So as you saw here, string dot ASCII letters, ASCII lowercase will give you the lowercase, a string of lowercase alphabets. Okay. So letters contains a string of lowercase alphabets. There is this new empty string in which you are appending another letters. Okay. In this for loop. So this, so you're passing a word over here. It is going to from the starting of the word to the end of the word, seeing each character, and then getting the index of that. So let's say, let me show you an example here. Okay, so I've called shift, sorry, let's say Saish. Oops, sorry, and I have to give another argument here or parameter value. Okay, so what's happening over here? So it's shifting S by 4. So A, B, C, D, E. So it's coming to E. Similarly, I, J, K, L, M. So it's coming to M, and S, S, T, U, V, W, and H, E, F, G, H, I, J, K, L. So it's shifting every letter in the string by value. So letters will contain all the lowercase one. Uh, then you are moving on to each character in this, and then you are seeing if this particular, so word of I will give you the ith character here, means the character at index I. So I in range len word, so it will go from 0 to 4 in this case. Okay, so if word I in letters, index equal to letters dot index. So why this case? If let's say if I have capital I over here, so if any character is not in this lowercase alphabet, so that character will remain as it is. Okay, so that is this case over here. If word I is in letters, then only shift it. Else, just keep that character as it is. So I is as it is. Whatever lowercase ones were there, they were changed. So the new is a empty string or like a string which is getting added to another character. So what is happening over here? Index plus value. Value is, let's say index is 25. Let me show it to you over here. So it is A, B, C, D, and so on. So letters dot index of A is 0, index of B is 1, and so on. Index of Z is 25. So if something is greater than 25, like let's say I want to shift Z to 25. So A is getting converted to E. So A plus 4 means 0 plus 4 is E. 5, sorry, 4, which is E. Now Z is 25 and 25 plus 4 is 29, which is not the case we want. We want it to go on to again to the initial characters. That's why there is this modular function over here, which will give you the remainder after dividing it with 26. Okay, So that's the reason this modulo is used over here. So is this particular function clear to everyone, what exactly it is doing? So this was just a simple application of, encrypting a message and use of this string library. Is it clear, everyone? We'll see more questions and we'll conclude the session shortly. We'll keep this session short. Okay. Yeah. So this we have already discussed. Values of CSV file are separated by try to write answer in chat. We have discussed this in one of the sessions earlier. So what is a CSV file? Yeah, for those of you who don't know, CSV file is comma separated values file. So in which, sorry, so the tab, so whatever you store in tabular format, let's say name, roll number, and so on. So let's say you have name, gender, roll number, and age, marks. So you can store all these values in comma separated fashion. So let's say name is Saish, male, and so on, 26, and so on. Okay. So you can have multiple entries in the CSV file. You need not have this header. So this is a header. So either you can keep it or you can just remove that. But header is necessary sometimes to, you can have a separate file in which you can have a header information, and then you can have this comma separated values over there. So you can read the CSV file in Python using CSV library and then extract certain information from the file. Like if you want to have the list of all the names, so you can have that. You can have the list of all the ages and then compute average of that and so on and do certain operations and so. So yeah, CSV in one such file. So there are other formats like TSV, tab separated values and so on. So you can have any kind of delimiter over there. So values of CSV files are separated by commas. What will happen if you don't check for a base case in recursion? It's simple. Yeah, so that's the answer. The program will enter into an infinite loop. Which of the following is true about recursion? Please try to answer in chat.
B.
Okay. So yeah, this was a little tricky. So the correct answer is recursion decreases the speed of the program because uh, it makes unnecessary function calls, as we saw earlier. So in certain cases, recursion may not be so easy to understand than the non-recursive programs. I'll try to find out some examples and we'll discuss this in next session. Like we need to discuss this as well as the other example in which yeah, we came across another example in which recursive code can be shorter than non-recursive code. So yeah, we will see this and this example and the other example in which recursion is not so easier to understand than the non-recursive programs. So yeah, please wait for that. Okay. So Yeah, so the correct answer over here is recursion decreases the speed of the program because it makes unnecessary function calls. Yeah, so that's it for today. So I tried to keep this session shorter. If you have any questions, please feel free to ask now. Ask them now. I'll be happy to answer whatever queries you may have relating to the concepts that we have discussed so far. Any queries? Anyone? Oh, Peep. Yeah, yeah. Thank you for reminding. Yeah. So, Mastan, so pip is some installer which you can use to install certain libraries in Python. So, let's say if I don't have a library, so let me think of a library. Yeah. So, pip. So normally, what you will write pip install and the library name. So let's say NumPy. NumPy is already installed in this, so it won't take. However, in the collab environment, since it is not a terminal, you'll have to write exclamation and then do pip install numpy. So it will say requirement already satisfied because numpy is already installed by default in collab. But however, if there is any library, let's say Python, I'm not sure if it is there. Yeah, this is also there. Mm, oops. Okay, so I can't think of any library which is not pre-installed in Colab. But yeah, so if you try to install something over here, uh, it will give you a kind of a progress bar for each of the required packages. If they are not there, it will try to install them as well. Like so, whatever dependencies each library might have. So, like for example, Keras might need a certain version of NumPy, certain version of SciPy, and so on. So it will try to reinstall that uh, versions of that library. However, if you don't want that to happen, like it might happen that in for certain program, you might need certain versions of these libraries. Like you need NumPy. So you can see the version over here. Okay, like NumPy is 1.26.4. There's NameX library 0.0.8 version, and so on. But for certain program, if you need some other version of NumPy, then in that case, it is recommended that you use virtual environment. So what these virtual environments are, these are like a separate environments that you can create in Python. So generally you use Python hyphen m venv and give the virtual environment name. So you can look into the details online, like some name. So once you get this virtual environment, you can activate that virtual environment and install all these packages like for a given specific version program with specific versions in that particular virtual environment. So in this case, you can do like this, like pip install. So NumPy is now set to 1.26.4. So if I want to install NumPy 1.25 or something, let me just see if it works. So it's invalid. But yeah, yeah. So sorry. Yeah. So you can see a progress bar over here. I'm trying to, so it is uninstalling the existing version of NumPy and will reinstall the newer version. So I'll have to restart the session here. Say, but in your terminal, it will be means installed automatically in that particular virtual environment. So please make sure that once you start coding, you should be taking care of all these things because Python will have lot of dependency issues for each kind of program when you will code like big programs for any machine learning algorithms or so on. So yeah, you have to take all these into consideration. So uh, by default, pip is installed once you install Python. However, if it is not, means if it is not install set to the latest version, so you can simply just do pip install upgrade pip, and it will install the latest version of the pip. In certain cases, pip3 might so if you have Python 2.7 and Python 3, nowadays nobody use Python 2.x. So everybody is using Python 3 by default. So, but however, in certain cases, if both the versions are available, so in that case, you might have to use pip3 instead of pip, because pip might install packages for Python 2.x and pip3 will install Python for Python 3.x. So yeah, these are some things you'll have to take into consideration. Okay. So just read up a bit on virtual environments in Python and how you can create that and install these packages over there with specific version as have shown over here. So it should be double equal to, not a single one. Okay. Recursion decreases the speed of the program. Yeah, Saki. So that was the example that I showed in Fibonacci series computation. So in Fibonacci, if it were like simply list. So let's say I have A equal to 0 and 1. This is the base case. And uh, let's say I want to compute the next element in this. So I can simply use this existing elements. So next will be A of, let's say, so in this case, the indexing will be from 0. So A of 1 plus A of 0. Okay. And then I can just do A dot append next. Sorry. So you got the next element. Similarly, I can repeat this recursively and get the nth element. So I got the third element, then I can get the fourth, fifth in a recursive way. Sorry, not recursive, iterative way. In this case, I'm not making calls to, so as we saw in the case of Fib 5, Fib 5 was calling Fib 4 plus Fib 3. And then this Fib 4 is again calling Fib 3 and Fib 2. And Fib 3 is also calling Fib 2. So that is like unnecessary calls are being made over here. Whereas you just need the previous two information, and if it is stored somewhere. So the problem with recursion is that it is not storing these values. Okay. So in that case, you are unnecessary making those computations again. Whereas the iterative way will be simple. Like you just have to, iterate till that. So you just have to repeat this particular process if you want to get. So this is, I got the third element. If I want to get the fifth element, I just have to do this 2 times again. That's it. So in this case, I'm appending the value. I'm storing the values as well over here. So it is consuming some extra space, but time-wise, it is faster compared to the recursive algorithm. Is it clear, Saki? Let me just do this again. Uh, so now I'll do A of 2 and A of 1. So this 2 and 1 are index actually. So you can see the next element is computed. You can write it in for loop. So I'm just trying to explain it. So here I'm not making unnecessary recursive calls. I'm just simply iterating over whatever information I have stored in this A. So I'm just using this values and then computing the next value. Madhuri, there is no such base book, but one resource that I'll recommend everyone is this W3 schools, which is very good. You can get the hold of Python syntax from here, and there are n number of different tutorials and forums wherein you can get solutions or like clarify your queries, whatever queries you may have relating to Python. So you can just put on your query, whatever code you are writing, and if you're facing any difficulty, you can put it on any search engine and you'll be redirected to any forum. That's what I generally follow. Even I don't remember all the syntax of Python. I simply just search, and there must be some forum wherein that thing is discussed. So that is what the basic uh, thing is to follow. But in case you have any specific query which you are not able to find out anywhere, please feel free to ask during the sessions. But W3 School is something which should help you out to get hold of the Python syntax, basic Python syntax. Yeah, thanks. Are there any other queries? Okay. Uh, yeah, before I move on, yeah, Masan, is that clear? Like all your queries regarding PIP? Okay, great. Yeah, so if there are no more queries, we'll conclude this session today. And I look forward to seeing you in the next session. It will be on Friday. Yeah, thank you. Thank you. I hope this session was helpful. Okay, so I'll end the call now. Are there any queries? Okay, somebody raised their hand. Okay, okay. Thank you everyone for joining. I'll end the call.